Number 3, as you can see, is an exponential decay problem, and it uses the E value. Do you see the E value up here? Okay, and we've been told that the patient is ingesting medicine containing A grams of a drug. The amount left in the patient's bloodstream after T hours is given by this equation. After how much time will exactly 1/3 of the drug still be circulating in the bloodstream? A couple things that I want you to see here. If we have the equation y is equal to a e to the negative 0.119 t power. Okay, remember that the a value typically is referring to the initial amount. The y value is going to be referring to the amount after the decay has occurred. So you could use a lot of values. I'm going to use the fact that 3 is 1/3 of 9 to help you to see how to solve this problem. So the choice of 9 and 3 is a very arbitrary one, but let's just assume that we started out with 9 grams of the drug, okay? And that means that if we started out with 9 grams of the drug, then we have 3, right? Because we know that 3 is 1/3 of 9, and we know it's exponential decay, which means that we have less at the end than what we have when we start, okay? Now, this is enough information to solve for t, because you see it's asking after how much time, okay? So the first thing we're going to do is divide both sides of the equation by 3, all right? So that gives us, I'm sorry, we're going to divide both sides of the equation by 9. That's kind of blonde move there. Okay, so now we have 1/3 equals e to the negative 0.119 t power. Now this is where we can use the rules that we learned from the lesson we did just a couple of days ago. We can raise both of these. We can take the natural log of both of them, okay? Take the natural log of this, which gives us 1/3, and take the natural log of this, which is e to the negative 0.119 t. Taking the log of both sides of an equation is something that's perfectly legal, just like adding the same thing to both sides is a perfectly legal move. Now, remember that when you have the natural log, that understood base is e, okay? Do you see that little understood base? So do you see that these two are the same? Which means that you know that the overall value of this whole thing right here is going to equal this, all right? So that means, at least for the right-hand side of the equal sign, we know that that's equal to negative 0.119 t. Now, what about this though? Well, enter the natural log of 1/3 into your calculator. If you do that, you'll discover that it's negative 1.10 approximately. Of course, I'm rounding here. Just leave that value in your calculator, and now we can solve for t. Divide both sides by 0.119 t and divide by 0.119 t. I'm thinking you should get t is equal to 9.23 seconds. So it's after 9 seconds that exactly 1/3 will be circulating in the bloodstream. Okay, fairly certain that the part that was the most maybe new for you was this part right here, taking the log of both sides, all right? And the reason that we knew to take the natural log rather than the log with base 10 was because of this e sitting here. And we just manipulated it so that we had these bases the same, which means that we have this equal to negative 0.119 t. And as you continue to practice these more, they'll feel a little less intimidating for you.